Hey Geo kids, it's Mrs. Fellon. I am going to walk through lesson 4.1 and I'm on page 94 of your student journals. So we're going to start by kind of going over some important vocab for this unit. And the first one is talking about a vector. And so what a vector is a line segment. So I'm just going to kind of draw, it looks like a ray. So it's like what they call a directed line segment. And so what it is it has like both direction and magnitude. So what I mean by that is it's like you're talking about moving a certain distance. It's like you're saying you're going to start at A and go to B, and you're moving in this direction. And so what you do is it kind of looks like a ray, and the symbols that we use is we talk about like this little kind of angle symbol almost. And when we're referring to vector AB, it looks like that. And so when we get into a couple examples, you'll see kind of how we're going to use a vector. But basically it talks about how you're going to translate or move an object. And so you're moving an object with a direction and with like a purpose, right? So like, for example, you were going to talk about kind of your horizontal and your vertical distances here. So kind of think about kind of like slope almost. And what we're going to do is we're going to start using these translations to help us kind of translate some of our objects around a grid. All right, so the initial point just kind of goes within a vector. It is the starting point. So I'm just going to put starting point of a vector. The terminal point is then the ending point of the vector. So we have the initial point and the terminal point. So in my diagram here, A is the initial point and B is my terminal point. The horizontal component, and I'm just going to kind of draw like a little example here. So I'm going to put A at the point 1, 1. I'm just going to draw a little graph. And then I'm going to put B at the point, let's do 3, 4. 1, 2, 3, 4. Okay. So this is B. So what we're talking about here is when we're referring to kind of the vector between these. So again, it has a direction, so it could be both positive or negative. When we talk about the horizontal component, what you're referring to is the distance along your X. So imagine like almost like you're kind of putting this into a right triangle, right? And so what you're doing is you're saying, okay, we're going this many, spaces to the right and this many spaces up. So my horizontal component here would be 2, and my vertical, so horizontal and vertical component would be 3. And so together, the horizontal and vertical component make what we call component form, which is just your horizontal component and then your vertical component. And so for my example here, I would say this is the vector 2, 3. And how we read this is we would say, okay, what that means is that I'm moving 2 in a positive direction on horizontally or on the x-axis, and I'm moving 3 in a positive direction or up on the y-axis. So reading this, it basically refers to kind of like how you read a point. We're talking about kind of moving in a direction. And that's really the biggest difference when it comes to a vector. You're going to talk a lot more about vectors in pre-calc and so forth, so they're going to come back, but this is just kind of an introduction. All right, so in this unit, we're talking about transformations. In a transformation, there are 4 different types of transformations. So there's something called a translation. And a translation is what I was referring to here with the vector. It's moving kind of left and right. So you're going to move the function or move your figure up and down, left and right. I should put up and down too. Okay, so then you have something called a rotation. And what you're going to do with a rotation is you're going to kind of like rotate it around a point. So it's going to be like if the point is, say, at the origin, you're going to rotate it 90 degrees, or you might rotate it 180 degrees. Then we're going to talk about something called a reflection. And you guys are probably familiar with reflections, right? So a reflection is over a line. So whether you reflect it over the x-axis or the y-axis, or maybe you even reflect it over the line y equals x or y equals 2. So you can reflect it over various different kinds of lines. But basically a reflection is just kind of a mirror image of each other. And then dilation. A dilation is the last transformation we're going to talk about in this unit. So I should probably number these. And basically a dilation scales your factor or scales your image up, or it scales it down. So it makes it bigger or it makes it smaller. So it's the only one that's really going to change the size of your image. So like all of these are just kind of moving it around, right? You're either moving it left, right, up, and down. You're either rotating or spinning it. You're either like flipping it, reflecting it, but you're not changing the actual look of the figure. Like let's say we're rotating a square, for example. It's not going to get bigger or smaller. It's just going to kind of change in terms of where it's positioned. But a dilation is going to be something different. So that's going to be the one that kind of doesn't really match the other one, so to speak. And it's going to be one where you change the actual size of the figure. All right, I need to talk to you about two other words here, and that's image and pre-image. So I want you to understand that when we talk about a pre-image, that's your original figure. So if I graph an isosceles triangle, my original figure that I graph is called my pre-image. And then my image is after I go ahead and apply my transformation. So I might start with like a square, and then I might translate it up 4 and right 6. And so where I end, like what that new figure would look like at the end, it would be considered my image. So we talked about a translation. So like I said, translation moves every point. So this is what we're going to kind of highlight today. A translation moves every point in your figure the same amount in the same direction. So like if I had, like I said, if I had an isosceles triangle, let's just make something up here, and I wanted to move it up and I wanted to move it right. Every figure or every point in here, if I moved this point to this point, if I moved it up, 6, and then I moved it right 8, every point in my figure is moved the exact same way. Up 6 and right 8. Up 6 and right 8. And so basically that's kind of where the vector is going to come into play. It's going to be, how you're going to move your figure around your grid. All right, so rigid. Rigid is, so when we talk about rigid, we're actually talking about a translation, a rotation, and a reflection. So a rigid is motion is something that preserves, I'm just going to write it down, preserves length and angle measure. So how I remember it is that it doesn't change the shape or the size. So I think of it as like shape and size. For me, that makes more sense. So like, for example, a translation is a rigid motion. And the reason why is because I'm not changing the actual figure, right? I'm just moving into a different location. A rotation would be a rigid motion. So same with a reflection. A dilation would not be a rigid motion because you're going to change the size. Remember how I talked about you're going to make it bigger or smaller. And so that's the only one of our transformations that we're going to talk about in this unit that is not a rigid motion. All right, so last and not least, but we're going to talk about a composition of transformations. And that means basically 2 or more. So 2 or more transformations together. So obviously we have to wait till we kind of learn some of this stuff, but basically it might be something like, okay, we're going to move this up 6 and right 8, and then we're going to reflect it over the x-axis. So what that is it's a translation followed by a reflection. So you're doing kind of 2 different types of transformations in one figure. And we're going to do that quite a bit. We're going to get into that a lot anyway, but that's something that we're going to kind of focus on in this unit is kind of the composition of transformations. All right, so that's all the vocab. I'm going to have you jump to page 95. And they kind of talk about vectors and stuff. So you guys read through all this stuff, and it talks about the initial point and so forth. I just kind of went over. And so I'm going to kind of scoot down to the end here. And we're going to talk about just kind of practicing like naming the vector. So it says name the vector and write its component form. So notice that a vector is a ray and it has a direction. So it's going from M to N, initial point to terminal point. So again, how you write it is you write it like array. So you have your initial point here and your terminal point there, and then you write the arrow from the initial point to the terminal point. So that's your vector. This is how we name the vector. And then in terms of component form, what I'm looking for here is your horizontal change and your vertical component. So this is 1, 2, 3, 4, and this is 1, 2, 3, 4, 5, 6. So my component form would be, I'm going to move positive 4, so I'm going to move 4 in the, like basically right in the horizontal direction, and I'm going to move up 6. So my component form would be 4, 6 is kind of how we say it. All right, take a look at the next one. So this one, I'm starting at B and going to A. So if I'm writing my vector, again, make sure you start with your initial point to your terminal point. So you're starting with B and going to A. So there's my vector. And I'm just going to kind of draw in like that right triangle of sorts. So this is 1, 1, 2, 3, 4, 5. So my horizontal, I'm going left this time. So you would call this -5. So I'm kind of going in the opposite direction, right? So this component form would be -5, which implies that we're moving left. And then from B to A, I moved down 1. To get from B to A, I had to move down 1. So what the vector is telling you, and so if I give you this, right, and I say, okay, here's vector BA, here's your component form, it's telling you how to move it. You're moving left 5 and down 1. So that's what the vector is basically doing there. Okay, so the last one, J to K, or actually it's K to J. So again, starting at your initial point, going to your terminal point, draw in the little arrow for your ray. And this time I'm going 1, 2, 3, 4, 5 left, and so that's 5, and then 1, 2, 3. So I'm going 5 left, so that'd be -5, and then up 3, so that'd be +3. And that's all you're really doing when you're talking about like writing a vector, all right? So that's, again, just kind of how you write a vector. All right, let's go to the next page. I'm not going to do all the ones on the next page, but I want to get you guys started on some of these, and that way you guys can do the rest. So what I thought I would do is I would do some of the even ones. So I'm going to do 4, 6, 8, and 10. I'm going to do those. And then I'm going to save the other ones for you guys to do either in class or for practice. All right, so what we're talking about here, and this one isn't a great example. You may have to use some graph paper if you want to graph this. It says you're here, they're giving you a pre-image, so they're giving you a triangle, and it has A, B, and C, and then they want you to translate it using this vector. So I want to show you how I want you to write this. So when we talk about an image, so like if I did A, B, and C, for example, this is what we call a pre-image, right? And then when we do our image, that's after we do the translation, we use this notation of A prime, B prime, and C prime. And basically what that means is this so you can tell the difference between what you did on a pre-image versus an image, right? So anything with just like A, B, and C, just like without anything on it, is going to be kind of your starting image. It's going to be your pre-image. And then after you apply one transformation, you kind of do this little dash, looks like one above that, and we just call it prime. So it's called A prime, B prime, C prime. And basically it's just notation to help us kind of dictate what we're doing or kind of where our ending point is. So for example, -4, 0. What this vector is telling me to do is go left 4 and change nothing on the y. So that's all I have to do is go left 4. So if I were going to write my components, so like my coordinates for my image, so after I do the translation, I'm going to take each of my points here. So in A, I'm going to take 1 and 2. I'm going to subtract 4 from the A value. So I'm going to get -3. And I'm not going to change the y value. So my A prime, after I do this transformation, will end at that point. B prime, same deal. We're going to subtract 4 from the x's, so I'm going to get 1, and I'm not going to change my y's. And then C prime, same deal, subtract 4, not change my y's. And so what we're doing here is we're graphing, or we're doing a translation for both. So they only give you one graph, which doesn't really help. Pay attention to your scales. They're counting 2's here. So if A is at the point 1, 2, and B is at the point 5, 1, and C is at the point 5, 4. Okay, so this was my pre-image. So that's that original image, all right? So that's my, and this was A, B, and C. Okay, it's awful small, I know, it's kind of annoying. And then if I translated it 4 units to the left, this is what it would look like. So -3, 2, this would be A, 1, 1 would be here, and 1, 4 would be here. So this would be A prime, B prime, C prime. Notice that I just kind of slid the triangle over, and that's exactly what a translation does. It slides your figure all around the grid. So to be honest with you, what I'm looking for here is this stuff. I'm looking for the like where it's going to be, obviously I want to pay attention to the graph, but I'm going to ask that you guys write down the ending values for all of your images. So I want to know what A prime is, what B prime is, and what C prime is. And that's really ultimately what I'm grading you on. All right, let's do number 6. So number 6 says no change in the x's, and I'm going to move -5 on the y. So that means I'm moving down 5. So again, I'm going to do A prime. So the x stays the same, move down 5 would be at -3. B prime, x stays the same, move down 5 would be at -4. C prime, x stays the same, move down 5 would be at -1. And so what I normally do is I write my coordinates and then graph it. I'm not going to graph this one just because it's going to get really kind of jumbled on this graph. So I want to grab another sheet of graph paper to kind of do those extra graphs on. All right, number 8. So number 8 has us talking about, it says, rule for the translation of the quadrilateral PQRS to quadrilateral P prime, Q prime, R prime, S prime. So basically what they're getting at here is they want you to start here and end here. So that's why they're giving you that notation. All right, so they're writing a rule, which means that you're kind of doing, a rule is a little bit different than a vector, okay? So a rule would be like what you're doing to x's and what you're doing to y's. So if you look down here, actually take a preview of what we did in 10, this is kind of what your rule would be. So it's a little different than kind of write it in vector form, and I'll show you both. But basically what you want to do is, since every point is moved the exact same direction, pick a point in your image and pick a point in your pre-image. So I'm going to pick P and P prime. Remember, we're going from P to P prime. And you want to look at your horizontal and your vertical component. So in this one, I went up 1, 2, 3, and I went 1, 2, 3, 4 to the right. So in vector form, did I do that right? In vector form, I went, my horizontal component was 4, right? So I went right 4, and my vertical component was 3. So I went right 4 and up 3. If you were to write this as an equation, you would say, okay, x and y implies, that's a little arrow, and you're going to say, well, I'm going to add 4 to my x's, and I'm going to add 3 to my y's. And so in translation, what this means, in vector form, this is what it would look like, and this is what our rule would look like. So the rule is just kind of like, okay, what are you doing to your x's and what are you doing to your y's? Oh, you're adding 4 to your x's and you're adding 3 to your y's. And so that would be your rule. All right, let's go on to number 10. Number 10 says, okay, let's see if we can use this rule. So now I'm giving you a rule, I'm asking you to apply it. So basically what I'm saying here is, okay, this is J, find the image. So I want you to find J prime. So if J is at 4 and I need to add 6 to my x's, I would take 6 plus 4 is 10. And then for my y's, I'm going to subtract 3. So I would get 2. So J prime is going to be at the point 10, comma. All right, so that's kind of your intro to translations. I would encourage you to try the other ones on this page, and that way you can get a little extra practice. And if you have any questions, of course, ask, and we'll have some assignments posted on Big Ideas as well for you to practice. All right, bring any questions to class. Bye, everyone.